right, so we'll do announcements. We'll talk about control flows and collections, and then you guys will do the Chapter 3 studio. So this, in case you missed it, last class, I do have new bookmarks up at the top of the class announcements channel in Slack in a Unit 2 folder where you can have access to the PDFs of my lecture slides, which have links to my code in them and screenshots, the lecture recordings, the studio review recordings, and graded assignment intros, which I haven't done any of so far for this unit, but I will be getting the assignment one out shortly. And now coming up, we've got a catch-up class on the 31st. You'll have a guest speaker from the company team at the very beginning of class in this Zoom room, and then you'll split out into your studio groups for the rest of the catch-up class. There's no class on Monday the 4th because of Labor Day. So you get a little bit of extra time before graded assignment 1 is due on the 7th. And that's going to cover all the concepts from chapters 1 through 4. So the stuff we talked about last class and tonight, and the things we're going to talk about next class. All right, so let's get into this. We're going to be talking about a lot of different things here, control flows and collections. So we're talking about data structures and the difference between arrays and collections. We'll talk about the array. We'll talk about 2 different collection types, the ArrayList and HashMap. And then we're also going to talk about conditionals and loops tonight. I'm going to stop and take questions 4 times, very briefly, just so we can hit it at different points along the way. But we are going to have, I've got a lot of live coding. I want to give you guys a lot of extra examples tonight. Sneha, do you have a question real quick?
Just making sure, by assignment 1, you mean assignment 0, right? I mean, it is listed as 0 to something.
No,
I was
it's assignment 1.
Oh,
yeah.
okay.
Yeah. Graded assignment 1. It's the console version of tech jobs. Yeah.
Oh, okay. Gotcha.
Okay, so let's get started on data structures. We are going to look at all this tonight, and you'll discover that there are quite a lot of differences to the way that Java handles data structures than the way that JavaScript does. So as you know, a data structure is a way to store multiple pieces of data, and you are accustomed to mostly working with arrays and objects in JavaScript. But there's a lot of different terms out there for how to store data in different languages. So you might see arrays and lists, array lists, dictionaries, maps. We're going to talk about a couple of those tonight. So in Java, there is an array type, but it's much more limited than what you're accustomed to with JavaScript. So I'm going to kind of go over some of the nuances of that. But it also has these collection types, and we're going to look at 2 of them, ArrayList and HashMap. And I want to talk for just a minute about the difference between arrays and collections. Arrays, you have to declare the size up front, and you can't change it. So you can't like add more things to it, like a JavaScript array, and make it grow, or take things out of it and make it shrink. An array is one size, but it does execute very quickly. So for certain things, it can be advantageous, but it takes more memory than collections do. There's pros and cons. It can hold both primitives and object types. And collections, on the other hand, the size can shrink or grow as needed. It does execute more slowly than arrays, but it takes less memory. So kind of the opposite pros and cons there. And collections can hold only object types, not primitives, which first sounds really restrictive, but you remember we talked about auto-boxing last class. I had forgotten to mention this because I was thinking more in terms of the way you're going to be using it way down the road at the end of the unit. But we actually are introducing autoboxing immediately, because we're going to be storing the wrapper class, the object classes of like character and integer and things like that in the array lists and hash maps, not their primitive counterparts. But it automatically converts them, so it's no problem. All right, let's talk about the array. So if you want to declare an empty array in Java, you just put brackets on the type to declare the array. And then you can give it a size and use bracket notation following that to add things to those indices. Oops, I went back too far. Let me go back. Okay, so look at this example. We have this, declares it as a type, being an array of integers. We give it a name, and then we say we want a new integer array, and I want it to have a size of 10. When we declare, one of strings, an array of strings, we'll call it names and say it's a new array of strings of size 3. So this is how you declare an empty array, give it a size, and then you could add things to it afterward. So like if I wanted to add things to my names array, I can say, names at index 0 is Isaac Asimov, names at index 1 is Arthur C. Clarke, and so on. So, that part probably feels a little bit familiar. It's just the declaration, the way that you have to actually create the array in the first place, that's quite different from what you're used to. So what if you wanted to initialize an array with values up front rather than an empty array? You can do that using curly braces. And so you would just put the values in between the curly braces instead of saying like new empty array with a size. And then it takes the length in order to get the size from that. And you can access the length yourself with .length. It's a property, not a method, so there's no parentheses. And again, I think I went a little too far. Well, yeah. So I mean, so you can see here with the examples, I've got the I'm declaring it with the type, an array of integers, 4 nums, and then I just put those nums in there with those curly braces, and it initializes it that way. Same thing with the string array of letters. I can just give it the 3 letters that I want it to hold. And so it has size 3, 4 nums has size 4, and you can check that out with .length. Okay, so if you want a print array, this is kind of interesting. If you print an array directly, it's going to be really strange. You'll get a very unexpected readout. It's going to give you its type and location in memory and not actually show you what the elements are. So what you can do about that is to import the arrays class, that's plural with an S, and use this method arrays.toString and then give it the array that you want to stringify. So you have to do this explicitly. So at the top of your file, you want to import java.util.arrays. And then in the main method, you've got your array, and you try to print it out, and you get this weird, combination of letters and characters and things. And it's just giving you that location in memory, telling you that it's an array of strings. But then if you actually use arrays.toString and give it the array, you actually see it more like what you were expecting, to actually see the array nicely printed with its elements, comma separated. So let's go over and do a little bit of coding on this. We're going to look at these array examples. I want to declare an empty array called hobbits, and it's going to be an array of strings. So string and brackets will be the type, and then I'll say hobbits equals new string of size 8. Or 9, apparently, because I missed the 8. There we go. I'm having a time. All right, there we go. Okay, so we have declared it. We've given it a size, and now we want to add information to it. So I'm going to say I want, hobbits at index 0 to be Frodo, and hobbits at index 1 to be Sam, and that's actually not what I meant to do. I meant to do it index 2. I'm going to skip around because I want to show you something interesting about how this works. We declared it of size 10, right? So what happens if you don't actually give values to every single one? What if you only put values in at certain indices? That's what I'm going to demonstrate. I'm going to do one more. Index 7, and we'll put Mary at index 7. Okay. So let's see what happens when we print an element at an index that doesn't have an assigned value, something other than one of the ones I chose. I'll say hobbits at index 1. So let's run this. I need to make sure I'm running the right one. Okay, so it says null. So when you have an array of strings, it will automatically just give every single element the value of null when it creates it here. So you'll have an array of 8 elements that are null, and then you start changing them. And so then what happens when you try to print it and see that, you'll see what the result is. But first We're just going to demonstrate what happens when you try to print it directly. So I'm just going to print hobbits just like that. And we see that, you know, the crazy characters again, right? L java.lang.string, and then it has this location after it. So that was not what we were going for. So let's come up here and actually use the arrays class to take care of this for us. So I'm going to print arrays, and I'm going to pull that in from java.util.toString and give it hobbits. Okay, let's run it again. Okay, so now we see Frodo, null, Sam, null, null, Pippin, null, Mary. So you can see that everywhere we actually gave it specific values after the fact, those values are there. And then everywhere we didn't, Java is holding, you know, those elements in place that they exist, but they're null. They just don't have a value yet. But it is exactly of size 8. Okay, so let's do this now where we initialize with values from the beginning instead of starting with an empty array. So I'm going to create an array of integers, so int array, and I'm going to call it fellowship. And I'm just going to give the number of the different races of beings that are part of this fellowship. For wizards, hobbits, elves, dwarves, and men. There was 1 wizard, 4 hobbits, 1 elf, 1 dwarf, and 2 men in the fellowship, right? And then I can print some sort of sentence that uses those values, right? So let's say there were oops. Oh, I need my plus sign. That's what I'm missing. All right. Fellowship at index 4, men in the fellowship of the ring. Okay. So let's run this. And we see there were 2 men in the fellowship of the ring, and it looks like I failed to put a space in there, so I'll fix that. Got to watch those spaces when you're doing this kind of concatenation. All right. And then the last thing we'll do here is actually print the entire thing using that same methodology, using the arrays class, arrays.toString, and then give it fellowship. Okay. And there we see it, 1, 4, 1, 1, 2. So we have all the values nicely printed out. Okay. So that's pretty much all you need to know about arrays, the basics of arrays. Let's talk about the array list. So this is one of the 2 types of collections we're going to talk about. Array lists are much more flexible than arrays. They allow any size. You can import the ArrayList class from the java.util package to declare one. And you want to make sure that the elements are going to be typed with the object type, that wrapper class. So integer instead of int, you know, double instead of lowercase double, etc. So you can see right here that I've got, you know, an empty array list that I can call by just invoking the constructor. So I give it a type. I say I want an array list that is of type. It's going to hold elements of type string. I'll call it fruits. And then I'll say that's a new array list. And then all you have to do is have the empty brackets and parentheses here. And that just says, okay, create an empty array list that is prepared to take elements if you want to later. And you do the same thing with different types, right? There are a number of different array list methods that you can use. When you want to add something to it, use .add. When you want to check how big it is, you can check it with .size instead of .length. And that is a method, so put the parentheses on it. You can use contains to go see if something exists in it. And you can use index of to find out exactly where an element is. If you want to sort an array, however, you need another class. You need the collections class because it's the one that has the sorting method in it. So you can just call it, you import collections from java.util and then just call collections.sort and give it the list, and it just goes and does it for you. And then the next time you do something with a list, it'll be sorted. So let's do a little bit of live coding on that, and then I'll take some questions about arrays and array lists. All right, so we're going to do some examples here on array lists. The first thing I want to do is to declare 2 empty array lists. We're going to have one for elves and one for their ages. So I'm going to say I want an array list, and I'm going to use tab here to make sure that import statement shows up at the top. And I'm going to give it, this one's going to be of type string, elves equals new array list, just like that. And then I'll do the second one will be of type integer to hold ints. And this one's going to be their ages, and I'll say new array list and just do an empty array list again. Okay, so we've got those, and now we want to add elements to them. So let's say we choose 4 well-known elves. I can say elves.add, and we'll say Legolas. He's a pretty well-known one. Wow, there we go. And how about Arwen, Elrond, and Galadriel. Okay, so that'll add those, and then we'll do the same thing with the ages. So it turns out, I looked this up, Legolas was approximately 2,931 years old at the time of the Fellowship of the Ring. And Arwen was approximately 2,901 years old. Elrond was approximately 6,497 years old, and Galadriel was over 8,000 years old, y'all. Crazy. Okay, so now let's print them, because we want to kind of see, we've told Java we want to add these values. Let's see what it looks like. These you can print directly. So I'm just going to print elves, and I'm going to print ages. All right, let's run it. Come up here and make sure I'm running the right file. Okay, so we have 2 nicely printed array lists. First one with the names of the elves, the second one with their ages. Good. So what if you want to use some of these methods, right? Let's print the size of the elves array list. So I'm just going to say print, oops, there we go, elves.size as a method. And then we'll check, I'm going to go ahead and code all this, and then we'll run it. We can print out the ages and see if it contains 2901, and we should get a true or false on that. And then we'll sort elves. So I'm going to need this collections class. So I'm going to make sure that I used tab to make sure that import showed up there. And then dot sort, and then I give it elves to sort for me. And then I'll print that so that we can see them in a different order now that I've sorted it. All right, let's print this again. I'm sorry, run it again is what I mean to say. Okay, so we got 4 is the size, true that the ages array does contain 2901. And then we see that they are now sorted in alphabetical order from Arwen to Legolas. So the only problem with this, of course, is, if we were really going to store data this way, we'd have a problem, because now the ages are not in the same order as the elves, and there's no way to correlate them, right? This is why they created hash maps. So we'll get into that in a second. But first, if I can find my mouse, who has questions about arrays and array lists? Anybody?
I do have a question. Can you go back to the last slide
Oops.
where it has the wrapper?
This one?
No, one more, I think. Yeah, this one right here.
Mhm.
So I'm still stuck on understanding like the object type versus the primitive, and we use the wrapper class on here.
Yeah, so the way that the ArrayList class is set up, I'm sorry, I didn't mean to click on that. I should point at it and not click on it. It just requires you to specify the type using the wrapper class, but then it uses autoboxing to automatically convert it because you are, actually storing just regular ints. So all of that is happening behind the scenes. You just have to make sure that when you declare the type that you use the wrapper class and not the primitive. I'm
Okay.
sorry, the wrapper class for the type, for the primitive type. Yeah.
Yep.
Okay.
Okay. Yeah, makes sense.
All right, Mel.
Yes. Is there a way to initialize an array list with variables, or not with variables, with values, in the way that you use curly braces to do that with the array?
There is. There's a couple ways to do it, and it requires a bit of extra syntax. And I have so much to cover tonight. It's the only reason I didn't bring it up yet. But I know there's going to be times in my future examples where I do show you how to do it. So don't worry about it too much. You don't need to know how to do it right this second, but I will be giving you examples in future classes of how to do it.
Great, thanks.
Sneha?
Oh, actually, Tracy has question in lecture chat and her same question. Can you do the arrays.toString in bracket array for arrays with any kind of value in it, like doubles or integers, or it just has to be string?
I'm sorry, can you repeat the question?
Can you do the arrays.toString in bracket array for arrays with any kind of value in it, like doubles or integers?
Are you talking you're talking about this one, the arrays.toString for arrays?
Uh-huh.
And
So,
you're
I mean, we did it for string array, right? So can we do it for double or integers array and convert them to string?
Oh, yeah. So it doesn't matter what the arrays hold.
Okay.
The toString method will stringify it, which means it just makes it printable in a way that it's easy to read and you can see all the elements. So
Oh,
even
so with the square
if
bracket.
the elements were integers or doubles or anything, yeah, it would still print them nicely for you. Yep.
Oh, I see. Thank you.
Okay, great. All right, well, let's move forward. We have more to talk about. I'm going to do hash maps, then we'll take a break, and then we'll come back and do conditionals and loops. Let's talk about hash maps. So the hash map stores key value pairs. And in JavaScript, you were accustomed to using just a general object is what we called it for storing key value pairs, right? But in Java, they reserve that term object to specifically mean an object of a class. In this case, we don't need to have a class set up in order to instantiate a hash map. We can just create a hash map independently. So that's an important distinction. We are going to be learning about classes next, like how to set up classes with constructors that can create, instances of the class with objects. So for now, we're just talking about a hash map being a data structure that holds key value pairs without having to be associated with any particular class. So you do import the hash map class in order to type it. And then you can declare an empty hash map simply by calling the constructor the same way that you do with ArrayList. So at the top of the file, you have your import statement where you're pulling that in from java.util, and then you have your declaration where you say, I want it to be of type hash map, and I want the key to be a string and the value to be an integer. And the keys and values can be any of those types. The keys don't have to be strings. So you just have to specify here what it's going to be, and then give it a name and say new hash map, and then just, empty brackets to create an empty hash map. And then you need, methods to actually be able to interact with it. So if you want to put values in key value pairs, you use .put. And you give it the key first and then the value. When you're ready to go get the value of a key, you just call get and give it the key. If you would like to get a set, which basically gives you an array of the key value pairs, but as an array, you call entry set. If you want just the keys in an array, you call key set. If you want just the values, you call values. If you want to check and see if a hash map has a key or not, you can use contains key and check for that key. If you want to check and see if a value exists, you can check with contains value. If you want to check the size, you use size, the same as you do with array lists. And then I want to talk just for a second about this map class, because it's different from the HashMap class, much like the collections class is different from ArrayList, and much like the arrays class is different from array. But you need it sometimes in order to work with hash maps. And we're going to see that when we talk about loops in a little while. I'll show you exactly how to make use of this. But just for now, just know that this map class has some extra functionality for you. You can loop over a hash map, and the map class will help you apply a type to both a key and a value at the same time, so that you can look at a pair at an entry at a time. So you'll use this map.entry as a type. And then you can just use get key and get value from each of those as you're looping through. And it's really, really helpful to be able to work with all these different entries that are part of a hash map. So more on that later. I wanted to go ahead and mention it. Let's actually just go ahead and do some brief examples here to look at setting up hash maps and using them. So I said a minute ago that it's not very useful to have the elves and their ages be in two different arrays, because the minute you sort one of them, they're not lined up at the same index anymore, right? So this is why hash maps are great, key value pairs. You can take related data and keep it together. So we're going to create a hash map that, and there's an error in this, that's okay, in the instructions. We're going to create a hash map called elf ages. I'm going to say I want it to be of type hash map with a string as the key and an integer as the value for each key value pair. And I'm going to say elf ages equals new hash map. And we'll just use the constructor and just create an empty one. And then we could add some data to it. So let's add these key value pairs that represent the elves and their ages. So I'm going to say elf ages dot put. This is how I do key value pairs. Legolas, oops, forgot my quotes. And 2931. I'll do elf ages dot put again with Arwen and her age. Elrond 6497, and dot put again for Galadriel and her age. Okay, so now we have all of them together. So let's print it. And just like with the ArrayList collection, with a hash map, you can print it directly and it'll look pretty nice. So it may not be like, you know, how you'd want to print it for certain applications, but it will, it's readable. So let's look at it. Oops, I'm going to run the wrong one because I forgot to actually, yeah, we're still looking at ArrayList. Let me run this one instead. There we go. Okay, so we see this, it presents it, when it stringifies it, it presents it with curly braces, and the key value pairs have an equal sign connecting them. So it's readable, right? It's perfectly fine for kind of a behind the scenes check on your data. Okay, so we see that we've got all that together. Now let's go and practice using some of these methods. We'll print the size. I'm going to say elf ages dot size, and we'll print the entry set. So I'll say elf ages dot entry set, and I'm going to go ahead and print this now so you can see before we do the rest of them, so you can see it for sure by itself. Okay, so it looks a little bit like this, but it's actually in an array list form where it has them you know, it's a special format. So you still see the equal sign because it's still correlating the key value pairs in a special way. But they're actually listed more like an array now. Okay, so let's print just the keys. Key set. And there you see you have a list of just the keys, all the names of the elves. And then if we do the opposite and print just the values, you have access to just the values. Right, okay. So now we can use these ones that return Boolean values, the contains. Let's check for a key and check for a value. So I'll say elf ages dot contains key, which is asking the question, does it contain it? Do we have Arwen in there? And it says true, we do see Arwen. What if I say, let's check the values with elf ages dot contains value, and then give it, 5,000, which we know is not in there. So we would expect this to return false. And it does, returns false. Okay, so that's hash maps. Just key value pairs, lots of methods to make it easy for you to access and work with the data. Does anybody have any questions about hash maps? Sneha?
Could you please explain the entry set? What was that? I missed that, sorry.
Yeah, okay, so entry set, I'll open it. Actually, I can just open it back up if I can. I lost my mouse. There we go. Okay, so you see when I print just the array by itself, it shows it in the curly braces. That's kind of the stringified hash map. I'm sorry, I said print array. I meant print hash map. That's the way it shows it. If you actually call for the entry set, it puts it in a list instead and says, okay, here's one key value pair, here's the next one, and they're actually elements. The pairs are elements, and each one is called an entry when you have them together. Okay. Any other questions? Devin?
Hi, do the hash maps only have single values for the keys? Is there something similar to JavaScript objects where let's see, a single object can have like multiple properties, like the earlier astronaut where you had ages, weights, names, etc., species?
So are you asking if you can have different types stored in the same one?
Yeah.
Yeah, you can. It's just that you have to type it more generically. So instead, when you create the thing to begin with, instead of saying integer here, if you wanted to be able to store multiple types as values, you would just say object. And that is like general enough as like a parent class that then all of those other types that are inherit from object, you have that, polymorphism going on where you can then have different types because ultimately they are all objects.
Okay, great. Thank you.
Yeah.
And can you actually do object, comma object?
Possibly. I've never tried that, but possibly, yeah.
Okay.
I'll put this back the way it was. Yeah, that would be a good thing to test out and see if that works. Because then, yeah, you could have like, but the problem is, if you end up in certain it really is going to depend on how the data is set up. If you end up in certain situations where you're like looping through those entries, then you're going to start running into problems with working with the data because it's not going to treat all the types the same. So it really does depend on what you're doing. Ryan? False alarm? Okay.
Sorry, I was muted. Are these one-to-one? Like, can you only have one value per key?
They are, but if you use an object type, you could have another data structure be a value that itself could hold other things. just like you did with objects in JavaScript, where you might have a value of one of your keys be an array, right? That then has a bunch of elements. So you could have you could have a hash map inside a hash map. I mean, you know, but you just have to make sure to type it that way. Yeah.
Thank you.
Yeah. Okay, we're going to move on because we still have a lot to cover. Let's take our 5-minute break, and when we come back, we will dive into conditionals.
Hello.
let's talk about conditionals. So with Java, there is no triple equal sign for strict equality and like double equal sign for loose equality. It's just double equal sign for strict equality. That's it in Java. And there are the other comparison operators that you're familiar with, using the combination of the bang, that exclamation mark to mean not equal, and then less than, and all of those are all the same. Logical operators and or and not are the same. So that's pretty straightforward. Let's see. I'm actually let's see how are we doing on time. I do have some examples for this, so we'll go ahead and jump into this. I'll be flipping back and forth, I think. So we can, do a little bit of this just to refresh your memory on how to set these up in case for some reason you have forgotten while we were working on HTML and CSS and all those things. So if we wanted to just say, 6 is not equal to 3 plus 4, we could just, set up that expression and have it evaluate true or false. Same thing here, we'll just print, let's say 8.146 is greater than or equal to 10. We can set up launch code. Oh, I don't think I put this on the slide. So equality with strings, I should add this to the slides. Equality with strings is special. You can't use the double equal with this. So you need to use dot equals. So if you wanted to compare launch code with lowercase launch code, if you're introducing case sensitivity measures, you can just okay, so my instruction says launch code. I'm sorry, I updated all of this and apparently did not catch all of my comments. This I actually was planning on doing Gandalf because that's cooler than this. So we'll just say let's take Gandalf, let's put it to lowercase, and then compare that with equals to lowercase Gandalf, and just say that are those things equal. We can do another expression using a logical operator and say 15 is greater than 10 and 15 is less than or equal to 20. And then the last one, and then we'll run all these, is does fellowship contain the substring boat or ship?
I think you typed an N and L instead of an N on the.
Oh, thank you. Yes, that would have caused a problem, wouldn't it have? Okay, thank you. Okay, so I'm going to check fellowship and say, does that contain boat? Or does fellowship contain ship? And as long as one of those two is true, the entire expression will be true. So let's go ahead and try this out or run it from here. Okay, so 6 is not equal to 3 plus 4, and 8.146 is not greater than or equal to 10. Gandalf is to lowercase is Gandalf. And so all of these, just evaluate just like you would expect them to. So, it's most of this is pretty much the same as the way that you were doing it, with the exception of using string equality. You have to use that equals method rather than using your operator, the double equal sign. And it's easy to forget that. I forget it from time to time. Okay, so let's talk about conditionals. So if, else, and else if. This syntax is identical to JavaScript. That's all I really need to say about that. So, let's say you have a string and you want to finish the string with some logic. The patient's temperature is, and then you check, is the temperature more than 99.5? It's too high. If it's less than 95, it's too low. Otherwise, you can say normal. This, it runs through, it finds, if something evaluates to true, then it will execute that code. Same as JavaScript. But there's also this thing called switch statements, which we didn't talk as much about, if at all, with JavaScript, but we're definitely going to cover it with Java. So here's the way this works. You have cases, and it just checks the value of some variable that you have passed in at the beginning. And you can check for specific values, and then you can also have a default case at the very end that will, catch any cases that don't match to any of them. And you use the break keyword to exit the switch statement once it finds something that it matches to. Otherwise, there's this thing called fall through where it would go down, and then it would still change your value with default unless you break out of it first. So that's the importance of the break keyword. Yeah, fall through. Okay, I just said that. You probably will use if else statements for a lot of things, but sometimes these are actually useful. They can be a lot clearer and help you set your code up in a cleaner way. It really just depends on what you're doing. So again, I'm going to point, because this is a new syntax for you, I'm going to point out all of these things. So here's the keyword switch. There's the case variable. That's the thing that you're checking the value of. And then you have all these, case keywords that say, what is it this match? Is it that match? And if there's no other matches, then you would, define that in the default section. So use those break keywords to exit the switch block. And that's pretty much it. So let's go over and code all of this. Let me close this so we can see our code here. All right, so we're going to, in order to evaluate this if, else, if, and else, I'm actually going to open up a scanner. So let's do that so we can take some user input. So if you remember from last class, you start with the class scanner as the type, and then name it something like input, and then just say we want a new scanner object and we want it to be user input. So we need to give it system.in in order for it to be user input scanner. All right, so now I can create a hash map like we did before. So I'll just say hash map, and I want it to be string and string. And we're gonna call this noble. And it's a new hash map. We'll just initialize a empty hash map. And we're not going to put anything into it until we actually get input from the user. So first we'll prompt them for a name. So I'll have to tell them what it is I want. And I'll say, please enter the name of a noble. And I could put like a colon there. Okay. And then I retrieve their answer and store it in a variable. So I'm going to call this noble name. And this is where I go and actually say, give me the value of the next line. I'm going to mention this again later, but when you're working with strings like this, the difference between next and next line is that next will give you a word at a time because it actually separates them out if there are spaces. So if you want everything that you put, if it has spaces and it has multiple words to be one string, you use next line instead. So we're going to do that just in case, we had more than one word. And then I'm going to store it. So I'm going to say, okay, we've got part of the information we need. I'm going to go ahead and put that in there. I'm going to give it the key name, and I'm going to give it that noble name that came from the user. So there's one, but we want one more piece of information. We want their title. So I'm going to just declare string title, but I'm not going to initialize it because we're going to use our logic to decide what the title is depending on what the name is. So we know that Amr becomes the king of Rohan, and Rohan, and Eowyn becomes the lady of Athelion. Aragorn becomes the king of Gondor. So this is the what we're going to work with. So first, I will say if noble name equals, and again, make sure you're using the equals method because they're strings, equals Amr, then we will say title is equal to King of Rohan. And then we can say else if noble name equals Eowyn, then title is going to be equal to Lady of Athelion. Except for we want the word of to not have a space in the middle of it. Okay. And then else if noble name equals Aragorn. Title is going to be King of Gondor. Okay. And then we'll have a case for, what happens if the name that's given to us isn't one of those three. We have to have a way to handle that. So right now, title is storing undefined. So what I'd like to do instead is to say, first I'm going to print a message to the console that says, sorry, I do not have information on that noble. And make it clear that we're not setting a value as expected. But then I will set title to just be null. And then we can set the title into that hash map by using noble.put and say, okay, the title is going to be whatever the value of title is now that we've finished our logic. It's going to be one of these 4 values, and then we can set it. Okay, let's print the map. So I will just print noble. And let's just go ahead and do this just to see how far we've gotten. I already have this up here. I can go ahead and just, all right, so please enter the name of a noble. So I'll go with Eowyn. Oh, and I put a space in it, and so it did not recognize it. Well, at least we know that the final else block works. Okay, let's do Aragorn. There we go. So you can see that we had set the name already when they gave it to us, and then it also set the title after it ran through the if else blocks. All right. I know you guys know how to do if else. I'm just using this opportunity to give you some more experience with using hash maps. How's that? All right, so let me close this for a second. So we can print a sentence using this information, just again, to practice these methods from the hash map. If I want to be able to retrieve information out of that map that we just set, I could do something like, oh no, let's just start with a name. Noble get, and then give a key and say, I want to go get the key, the value for the key name. And I'll concatenate that with is, and then do noble.get title. So let's run that. And then, depending on which name we give it. All right, let's do a different one this time. All right, Amorous King of Rohan. So Rohan. Okay, and I said, don't close the scanner yet because we're going to use it again. We're going to use it with the switch statements. So now let's do something similar. We'll practice a little more with using these hash maps. We're going to create another one that this time we're going to get information about an elf. So we'll say noble.put, go with title. Oh, I'm sorry. I am on the wrong thing. I'm apparently so tired that I did not even realize that I was. All right. Okay, so I'm going to create a hash map that is of type string and string, same as before. And this time I'll call it elf and say new hash map. And then it'll just be an empty hash map. We're going to prompt the user for a name. So similar to before, I'll just say, please enter the name of an elf. And then we'll retrieve that from them and store it in a string elf name. Input dot next line. Okay. Then we have the name, we can go ahead and store it in the map. So I'll say elf.put name. Okay. Oops, sorry, elf name. Yeah, we want to store the value as the value that came back. Okay. And then we'll declare a string here, realm, but we won't initialize it yet because we're going to assign the value using the logic in the switch statement. Okay, so we have three different elves that we, have from three different realms. So we're going to assign the values depending on which elf is in which realm. All right, so we'll start with switch keyword and then give it that the case variable elf name. This is what we're checking for. And we'll say case Legolas and put a colon and then say, if that's the case, we want realm to be equal to the woodland realm. And then we want to break out because we found what we were looking for. There we go. For the case of Elrond, the realm is going to be equal to Rivendell. And we also want to break out of that. And if the case is Galadriel, then the realm is going to be Lothlorien. I have to do this right. Okay. And then we'll have a default, just in case we don't give one of those three names. So this is where we say default, and I'll print a little, message, sorry, with 3 R's. Oh, wow. All right. I don't have information on that elf. And then we can just assign realm to null, just like we did before with the nobles titles. We'll set the realm into the map with one of those 4 values. So we'll go to elf.put, give the key as realm, and then say elf, oh, I just set it as realm, didn't I? There we go. And realm is going to be the value that's set for that key. We'll print it and see what we have. And then we can also print a sentence here like we did before and, use those HashMap methods. So I'll print elf.get, and I'll get the name of the elf, plus is from, plus elf.get the realm. All right. And then the last thing we want to do now that we're done is close the scanner. So I'll say input.close. Oh, good heavens. Okay, let's run it. And I need to run. Yep, that's right. Okay. All right, so we'll enter the name of a noble. Dang it. Okay. Do Aowen. Aowen is Lady of Athelion. Please enter the name of an elf. I'll do Legolas. Legolas is from the Woodland Realm. So there you have it. We have, successfully run some logic through. We've done a little extra practice there with hash maps, which is always useful. So now let's go talk about, nope, I'm gonna see if you guys have any questions before we do loops. Does anybody have any questions about conditional stuff? Mad?
So the textbook touched on this a little bit, and it might not be, we might not have time for it. So, but can you give an example of like a time when it's a good option to use a switch statement over if else? Because it seemed like the book's like, yeah, usually not.
Yeah, it's one of those things, like every once in a while, it's just a little cleaner. My examples here were so simple to begin with that it looks like, why use one over the other, right? Because they were so simple. But in some cases, you might have something that's complex enough that when you start to put it together with if else, it gets a little unruly. And I don't have time to like work up a whole thing.
Yeah,
what you could do is Google, why use a switch statement over if else, because I'm sure there are good examples out there that would be, quickly arrived at with a little
Yeah,
Googling.
that's
Because there are cases I've in my professional experience, I've used a couple switch statements a couple of times, but the vast majority of the time I've used if else. Although if it's super simple, I'm using ternaries because
yeah, right.
Yeah.
Okay.
Yeah.
Thank you.
Sneha?
So to follow up on that, maybe we could use it, for example, the input is different types, and there are a lot of cases, and can we call functions in switch statements? Like maybe we call different function based on that input, something like that.
Yeah, you can do anything you want. Everything like let's see, everything, let me get to the right place. Yeah, here, these are like however many lines of code you want to execute for that case. So you could have a lot of different things going on. Yeah.
Okay.
Yeah, it's just a different format that is a little bit cleaner because you don't have all of the brackets, all over the place. It's not quite as dense. It's a little, just easier to read in some cases. Yeah. Okay. Yeah. So let's get to our last topic. We're going to talk about loops. There are multiple types of loops we're going to discuss, and then I'm going to give you some examples of each of these. So the for loop is almost identical to JavaScript. The difference is in JavaScript, when you're declaring that local variable I, you're using let, but with Java, you have to actually give it its type. So we're saying int I equals 1. And this is an example of where you would just run 1 through 10 and print out each of the numbers. It's a very simple example. So that's it. It's just use int instead of let. Yeah, there we go. I said all of this, but I was not continuing to click. So there you go. Just make sure you set that type in and you'll be good. So let's go over and do a quick example of this. I've got an array of strings here called battles where I have initialized it with 5 different strings. And I just want to construct a basic for loop to print each battle. So I'm just going to say for, and I'm going to say int I equals 0, because I'm basing this on an array. So I want to do it based on the indices. And then I'm just going to say, battles.length, and then increment each time. And I'll just print battles at index I and run this. Come on. There we go. There you go. And you see each one printed out at a time, one at a time. Okay, so that's very straightforward. For each has a slightly different syntax, but it's great for iterating through arrays and collections. So you might start out with something like this, like an array of words. You make sure to declare the type of whatever local variable you create to represent that element. And then you use a colon to separate that local variable from the collection that you're going through. So just remember to use a colon there instead of some sort of word like of or in or whatever. And that's pretty much it. But there again, make sure you're giving that a type instead of using a keyword like let, which doesn't exist in Java. And let's see, I think I have a couple more. Yeah, there you go. And there's that local variable word, so that each time around on the loop, it accesses the value of the element. And this is the original array that it's coming from. Okay, so let's do this basic example, and then we're going to talk about how to use the for each loop with maps. And that was what I was alluding to earlier when we were talking about the map class. Let me get this closed so that we have more space. Here we go. Okay. Nope, we want this one. Okay, so I have a string of words, you shall not pass. And we're going to create a for each loop to print each of these one at a time. So I'm going to set this up just like you saw it on the slide. I'm just going to say for string word of words and just print word. That's simple. And then we have it. You shall not pass. All right. Speaking of you shall not pass, we are going to do an example about the Mines of Moria in a second, but let's talk about this first. So the for each loop with maps, you have this map class that allows you to apply a type to the entire entry, the key value pair, and while you're iterating through all of the entries from a hash map. So you're going to use these methods get key and get value to access those keys and values from the entry once you have created it as the thing that represents the pair. So this syntax is, the map gives you that type. It says, here's the way you can type an entry, a key value pair, and that you can apply that to a variable. And I called it entry because that's pretty straightforward, but you could call it something else if it had a very specific meaning. And we say, that represents that entire pair. But then I want to get just the key, or I want to get just the value. That's where I use get key and get value down here, these map methods. And then of course, this is incorrect because I am so sorry, this is incorrect. This should say my map dot get entries. So let me show you what this looks like actually in practice. I'll have to fix that slide. Sorry about that. Let's see if I can get back over here. Sorry guys, give me just a second. All right, here we go. Yeah. So we're going to start easy. We're going to use this just to go through the keys and just to go through the values. But the importance is that you use the methods of the HashMap class to get the array that you're looking for, and that's what you're actually iterating through. So I'm going to do first loop through the keys of all of these locations that we've got in this hash map with all of these different pieces of information about Moria. So I'll say for, and then string key. I'm just going to keep it real simple. And I'll say Moria dot key set. Yeah, I actually misspoke earlier when I said get entries. It should have been entry set, but we'll get there. Okay. And then we'll just, print that key so we can just see it. We'll do the same thing here for the values. We'll say for string value of, and we put a space here so you can see that colon a little more clearly. Moria dot values. And then I can print just the, each value as I go through. Let's go ahead and run this, and then we'll do the entries in a second. That's the more complicated syntax. Okay, so we see all of these keys: king, founder, name, ancient name, location, monster. And then we see all of the corresponding values, Balin, Durin, the Mines of Moria, Khazad-dûm, the Misty Mountains, and Balrog. Which don't make a whole lot of sense until we actually see them all together. So let's do the last one, which is to actually loop through the entries, the pairs, and then we'll be able to see them together. So we'll start with for, and then this is where we need the map class. So I'm going to go pull that in from java.util, and then say I want map.entry, and then we know that these, the keys and the values are both strings. So we want to make sure those types are set correctly. And then we can just call it entry or whatever, but it represents the pairs. This is what's important. And this is what I did wrong on the slide. We want to actually get the entry set so that it actually gets us an array of those key value pairs instead of just trying to go directly through the hash map. That won't work. Okay. And now for each one, we can print a sentence that actually makes a lot more sense in putting these keys and values together. So I'm going to see the entry dot get key, which, get key is a method of the map class that's coming because we're calling it on this entry, right? So that's actually of the map class, not the HashMap class. And I'll say of Moria is, and then I'll do the same thing for the value, get value. All right, so let's run this. And then we should see the sentences for each of these to come out together. There we go. The king of Moria is Balin. The founder of Moria is Durin. The name of Moria is the mines of Moria. The ancient name is Khazad-dûm, et cetera, et cetera. That's pretty much all there is to that. But when you're working with hash maps and you want to access, just the keys or just the values, or maybe both, these are all the different ways that you can use this for each loop to your advantage to be able to access it. And just remember, you have to pull in that map class in order to type this pair when you get the entry set out of the hash map. All right, let's do while loops and then do while loops, and then we're done. All right, so while loops. This syntax is absolutely identical to JavaScript because you're not actually having to add any sort of types once you set up the loop itself. I apologize. Let me get back to this. There you go. Okay, so let's say we have an array of ints, a whole bunch of numbers in the array that are set up. And we want to loop through this, but we also need an index in order to track that if we're gonna loop through this way with a while loop. But the idea here is that we only want to loop through the numbers as long as they're less than 100. So we set this condition so that it checks on every loop if that's still true or if it's false, and it only continues as long as it's true. And this is pretty much the example we're going to do here, except for I called it orcs. So you've got all these orcs coming at you, and first you see 2 of them, and then you say, oh crap, now there's 14 and 33 and 57. And then by the time it finally gets to 100, you're like, I'm not counting anymore, I'm just fighting, right? So that's my story, and I'm sticking with it. So we're going to construct a while loop to do this. First, I have to have an index. So I'm going to say int index equals 0. So I have somewhere to start. And then I'm going to go through and say, while orcs at index 0 is less than 100, print the number of orcs. So we'll just say print orcs at index I, or index in this case. There we go. And then to avoid having a infinite loop, we have to actually increase I, and I keep saying I because I'm used to working with, old fork. So it should be index plus, right? So whatever you do, if you're kind of manually controlling that means you have to make sure that you're going to keep increasing it. But, in this situation, when we don't necessarily want to go all the way through it, a while loop is more appropriate than a for loop. Okay, so let's run this. All right, so we see 2, 4, 33, 57. And it looks like my logic did not work. Something is wrong. So let's go and check this because it did go all the way through and then tried to keep going with an index that didn't exist.
Carrie, shouldn't it be orcs and index in the brackets instead of 0?
Yeah.
Or...
Yep, absolutely. Yep, you caught it. All right. So I'll run it again. Yes, because if you're going to base it on the current index, then you have to check a different one every time. Good catch. Okay, so now we get all the way up to 94, but we don't go any further. So that's what we were expecting. Great. All right, so while loop, same old, right? A do while loop is a little different because it will always run once. You tell it what to do, and then you add the condition, the while condition after the fact to say, now go check and see if you need to do it again, but it will definitely always run once. And it's really, it's the same as JavaScript. JavaScript runs just like this, but it's really helpful in certain situations where maybe you need it to do something once, And then if you're going to repeat it, you have to write all of those lines of code again, and it's duplicated code, right? So a do while loop will let you just put it all in there once and run it at least once. Okay, so we can, sorry, give me a second. I'll make sure. Yes, okay, there's one more bullet point here. Don't forget to put a semicolon at the end. This is different than all of the other loops you're used to, where they typically don't have that, but because of the way this is structured with this extra syntax after the bracket, you do actually put a semicolon on it. All right, let me pull this down and we will keep going here. All right, so we're going to use a little bit of, we're going to use user input. So we're going to set up a scanner here. And we're going to actually make sure that we are asking the user for a book title, but we want to be able to make it to where we can keep asking them for more titles and put it inside this array list of book titles up here. So you can see I have declared book titles as an empty array list. We want to start adding things through it, excuse me. So I'm going to set up scanner input equals new scanner, and I do need to import that class. There we go. And give it system.in for user input. Okay, so I already have the array list. I don't need that. So I'm going to set up a temporary variable. I mean, not temporary. It's the variable that I want to use to every time it loops around, I'm just going to use that to grab the user input for that loop. So I'm going to go ahead and declare it so that I can just keep reusing it afterward. And then I'm also going to declare a variable that I need just for managing the while loop. So I'm going to have a Boolean is quitting because we're basically going to give the user a chance to tell us when they're ready to quit. So I'm going to say is quitting is false. Now I have what I need to set this up. So again, you put the do and the brackets, and then after that, you do the while with the condition and a semicolon. So we're going to say while not is quitting. As long as they still don't want to quit, then we're going to continue looping, but we definitely are going to do this at least once. So first, we will ask them for a book. Please enter a book title or quit. And give them a chance to do one or the other. And then we'll say the title is equal to input.nextLine. And again, we're using next line because we want to make sure if the title has multiple words with spaces in between, that it actually treats it all as one string, which next will not do. It will separate them. And then we'll check to see if is quitting should be changed or not. So is quitting is going to be equal to title to lowercase. This is where we're going to make it possible for them to enter quit in any case they want to, and it'll still work. So if we take what they give us and it equals quit lowercase, then this will return either true or false, and we'll update this value of is quitting. And then we can say if not is quitting, we'll go ahead and add to book titles and say book titles.add title. Okay, so we don't want to actually do that until we know that what they gave us is in fact a title and isn't quitting. That's the point behind that. And then it'll just check and see if they actually do want to continue or not, and it should loop around. And then of course, after that's done, we can print the entire thing to see what all the books are that are in that array list. And we can close the scanner. Okay, let's run it. All right, it says, please enter a book title or quit. So I'll say The Hobbit. Enter a book title or quit. I'll say The Fellowship of the Ring. And The Two Towers. And The Return of the King. And then I'll say quit. And we see The Hobbit, The Fellowship of the Ring, The Two Towers, and The Return of the King have all been added to our array list. And we only had to set that all up once because we did it with a do while loop, rather than having to have all this separately first before we started checking if they wanted to do it again. Okay, does anybody have any questions about these loops? Mad?
Just quick, I think you said you can use a do while loop in JavaScript too?
Yeah.
Right, okay, cool.
We just didn't
Awesome.
cover it.
Yeah.
Anybody else got a question? Nope. Okay. All right. So that's it for tonight's lecture. On Monday, we're going to do classes part 1. This is the chapter 4 prep work that you'll need to do. And then on the 31st is catch-up class with a guest speaker. Labor Day is on the 4th, so there's no class at all. And then on the 7th, that says chapter 5, and it should say, I'm sorry, that says chapter 4, and it should say chapter 5. I'll fix that. But your graded assignment number 1 is due that night. There have been some people who have asked whether that's a drop deadline or not. It is not. Unit 2 works like pretty much the rest of Unit 1 did, where you just need to use those deadlines to keep yourself on track. But it's okay if you're a couple days, behind, because you really just have them all turned in at the end of the unit in order to proceed to Unit 3. So, treat them. I mean, I think mentally it's a good idea to treat it like a hard deadline, because it'll help you, stay on track. You'll make time and put in the time you need to get it done so that you don't get too far behind. Okay, so that's that. I'm going to talk about the studio. I forgot to put my bullet points in. That's funny. Okay, let's talk about the studio though, because, and I think this might be the old curriculum. No, it's not. I changed it. Good. Okay, so this is something I wanted to mention to you before you start this. You're basically going to be taking a quote, like this quote from Hidden Figures, and counting all of the characters so that you can produce output like this in the console. So you'll have to do a number of operations, including conditionals and looping and these types of things, and choose a data structure that works well. But they talk about here about using the directories that are in your existing Java Web Dev projects repository. And that's true, but they want you to create a new IntelliJ project to do this. So there's 2 things I want to say about that. One is you're going to have to do that by closing out of your Java Web Dev projects in IntelliJ and say, I want to open a new IntelliJ project, and let it, and then go to the directory that in there through that process and create the studio directory and tell it you want to give it this name and let it create it. And then you want to make sure that it's opening only that project and not the entire Java Web Dev projects, because then IntelliJ doesn't know which project to run. It's going to keep trying to run the bigger project, and it's not going to be able to just run this one. So don't open up this. Actually just create a new project in IntelliJ and use their little wizard to do that, and then it'll open it up. And you want just this project to be open in order to run it. Okay. And then they don't tell you here about like adding the packages and all that stuff. So don't forget, you want to go to the Java folder and you want to add org and launch code as the packages, and then you want to put your classes inside there. And then you can kind of move forward and just follow the instructions to do the rest. The first part's pretty easy. The bonus missions, start to get a little bit more work here. And then there is a super bonus, a super duper bonus. That's probably the hardest bonus mission I've ever seen, where they want you to read the string in from a file, and it will take some Googling and some, trial and error to get it right. But I know some of you are up for it, who are really, really always wanting to have super big challenges. And I do cover it in my video. So when you guys get access later tonight to the review, I do cover the super bonus as well as the other bonus missions. See you. I'll get those videos up later tonight, and then I will see you guys on Monday.
Thanks, Carrie.
Thank you, Carrie.
Thanks, Carrie.
Bye.